In this video, we are going to introduce sequences in series, and we're just going to kind of learn some common language that I'm going to use in the later videos. So first off, let's discuss what a finite versus an infinite sequence is. And so a finite sequence is a function that has a set of natural numbers in the form of this as its domain. An infinite sequence has the set of natural numbers as its domain. So let me kind of hash that out and explain that. So we're looking at really numbers that follow a pattern, okay? So if I look down here, let's first do a finite sequence. So a finite sequence could be the numbers 5, 7, 9, 11, and 13, okay? So these would be the elements of the sequence. These are the numbers in the sequence where I would refer to this number being in position 1, this number being in position 2, this number in position 3, this number in position 4, this number in position 5. This is a finite sequence because it ends. Okay, this one has 5 terms. If you had even 10 terms, even 1,000 terms, that's a finite sequence because it doesn't go on forever. Okay, we also can have an infinite sequence, which would be the same thing. So I could have the same sequence, but if I ended it with a kind of a dot, 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 and ellipse to kind of show that it keeps going, we could have the same start to the domain. We have the 3rd term, the 4th term, and the 5th term, but it doesn't stop there. It had the 6th, 7th, 8th, on and to include all natural numbers. So these numbers up here that I'm showing as the position in the sequence, like 1st term, 2nd term, so on and so forth, that's kind of like our domain. And then, and then this down here, the actual value of each term is like our range. And that applies to the finite sequence as well. The position where it is makes up the domain. And then the actual value of each term in the sequence, like the 13, would be an element of the range. And you can see that, and I want to kind of keep drawing this back to our definition, a finite sequence has a set of numbers in this form as its domain. For example, if this is my 1st term and this is my 2nd term, it doesn't make sense to have a 1.5th term or a 2.97th term. We're only referred to them by whole number terms because that's the position. It's going to be the 88th number. It's going to be the 102nd number. That's why our domain is going to be in this form. It's discrete. It's not what we call continuous. And then the same thing for the infinite sequence, just knowing that this keeps going to include all natural numbers. It goes on to infinity. And so let's look at some examples of types of sequences. These two sequences I've mentioned are not the only type of sequence, but that one that I did just mention is our first one that we're going to discuss. This is let me back up. This is an arithmetic sequence, okay? And so, like for example, I just gave you, what did I say, 5, 7, 9, 11, dot, dot, dot. That's what we call an arithmetic sequence because it's the sequences that have a common difference, meaning you add or subtract to get to the next term. So I want you to be able to look at the sequence and identify that it's arithmetic because it has a common difference. And what that common difference is it's a 2 in this case. I could even do this. I could do 100, 95, 90, 85, so on and so forth for an infinite sequence. And here our common difference would be a -5 because we are subtracting each time. So we just need to recognize if it has a common difference, okay, meaning that we add or subtract each time, that's how we know it's an arithmetic sequence. Now, let's look at a geometric sequence, okay? So we got a geometric sequence, and these would be a sequence of terms that have a common ratio, which means you multiply or divide to get to the next term. And so just a simple example of that, let's go 3, 6, 12, 24, so on and so forth. And you can see that to get to the next number in the sequence, we're not going +3 every time, but we're actually multiplying by 2 every time. So that 2 would be our common ratio, okay? And we call it a common ratio because I could write it as a ratio. I could say 24 over 12 is 2, 12 over 6 is 2, and 6 over 3 is 2, okay? But I could have one that decreased the same way. I could have one that, like for example, I'll start with 100 again. We go 100, 50, 25, 12.5, dot, dot, dot. And so right here we can see that we're actually, you could call it dividing by 2, and I know that I have divide here in the definition, but really I want you to think about this as multiplying by 1/2, okay? So here our common ratio would be 1/2, okay? Because once again I could write as a ratio, 50 over 100 is 1/2, 25 over 50 is 1/2, 12.5 over 25 is 1/2, okay? An interesting question for a later video that we're not going to discuss here is if this is decreasing, when does it get to 0? Okay, kind of leave you with a cliffhanger right there. We'll discuss that later. And let's look at Fibonacci sequence. This is a famous sequence, but it basically, I'll just kind of write it out. 1, 1, 2, 3, 5, 8, 13, and I could keep going. And you might be looking at this thinking, okay, what's the pattern here? I don't get it. Oh, actually, you should know the pattern because I wrote it in as a definition right here. But each term is the sum of the previous two terms. For example, 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8, so on and so forth. But just know that that's called the Fibonacci sequence. And lastly, I mean, this is not all the types of sequences, but these are just some of the more popular ones. But a harmonic sequence would be a sequence where the reciprocals of the terms are an arithmetic sequence. So I'll kind of use this arithmetic sequence. And so a harmonic sequence would just be 1 over each of those numbers. 1/5, 1/7, 1/9, 1/11, so on and so forth. So there's a lot of different harmonic sequences you could have, just like you have a lot of different geometric and a lot of different arithmetic. But if someone's referring to a Fibonacci sequence, they're probably referring to just this right here. And those are your types of sequences. Not all types, but I would expect you to be able to, given a sequence, identify which of these categories it falls in.